Find the elevation at point D in feet. In this problem, points A, B, C, and D are positioned in order along a soil profile. The profile view shows the locations of these points with an exaggerated vertical scale. The elevation of point A is provided, as well as survey data from a total station. To find the elevation at point D, we can set it equal to the elevation at point C plus the change in elevation from point C to point D. We can determine the change in elevation from the survey data, but we don't know the elevation at point C. We can equate the elevation of point C to the elevation at point B plus the change in elevation from point B to point C. And finally, we can find the elevation at point B by adding the elevation at point A to the change in elevation from point A to point B. We will solve this last equation first, because the problem provides the elevation at point A. And the change in elevations for all three courses can be calculated using the survey data. The first two rows of the data refer to when the total station is set up at point B and takes a reading at point A and C. The zenith angle is the angular measurement between the line of sight through the total station and a point directly above the total station. The slope distance is the length measurement between the total station and the prism. We'll abbreviate the zenith as Z and the slope distance as SD. We'll add another column to our table for the calculated change in elevation between 2 points in feet. The change in elevation from point A to point B is the same as the negative change in elevation from point B to point A. The change in elevation from point B to point A equals the slope distance BA times the cosine of the zenith angle BA. Since the height of the prism and the height of the instrument is not provided, we'll assume these measurements need not be considered for the calculation. After plugging in the known survey data, the change in elevation from point B to A equals negative 2.08 feet. This means the elevation from point B is 2.08 feet higher than the elevation at point A. So the elevation at point B equals 363.88 feet. Now we can move on to the second sighting from point B to point C. To find the elevation at point C, we'll add the elevation at point B to the change in elevation from point B to point C. The change in elevation between points B and C equal the slope distance from B to C times the cosine of the zenith angle BC. After plugging in the given values, this change in elevation equals negative 11.36 feet. Since we've also been given survey data for the zenith and slope distance, when the total station is set up at point C and sighting at point B, we'll calculate the change in elevation between points B and C a second time, and then average the two values out. After plugging in the slope data and the zenith angle, the change in elevation from point C to point B equals 11.36 feet. Therefore, the foresight and backsight measurements yielded the same change in elevation between points B and C, which we'll use, 11.36 feet, to calculate the elevation at point C, which equals 352.52 feet. Next, we'll compute the elevation at point D by adding the elevation at point C to the change in elevation from point C to point D. This change in elevation equals the slope distance from point C to point D times the cosine of the azimuth CD. Plugging in these values for the survey data, the change in elevation equals 1.95 feet. Lastly, we'll solve for the elevation at point D, where 352.52 feet plus 1.95 feet equals 354.47 feet. When reviewing the possible solutions, the answer is C.